Hi, I'm Vishal. Let us explore about why the speed of light is constant. From our daily experience, we know that speed gets transferred from one moving object to the other.
Let us experiment starting here. If I throw the ball,
It reaches a point there. Now if I run along and throw the ball, it reaches a farther distance. This very principle of velocity addition is used in the launch of spaceships. Multi-stage rockets are used to achieve very high speeds, where the speed of one stage is added to the next. Now let us try to add speed to light. If we repeat our experiments with laser flash, what happens? If we mount the laser on spaceship, for all three scenarios, the speed of light is constant. Why? What works around us is not working with light. Why aren't we able to add speed to light? As we all know, the speed of light in vacuum is constant, with a value of 3 lakh km per second. Isn't it strange? Let us give some thought to our experiment. The constant speed of light has puzzled many scientists. The space around us is three-dimensional, consisting of the horizontal x-axis, vertical y-axis, and the depth as z-axis. If I move along, say, the horizontal x-axis, my speed is distance traveled by total time taken. The Earth rotates around itself and around the Sun. Everything moves in the universe. If we take a closer look at our experiment, because of the Earth's rotation, my position has changed as I observe the spaceship and the light from it. So my coordinates have changed from the original reference at the origin. In a similar way, the coordinate plane for a spaceship has also changed. I, being stationed on the Earth, the spaceship in the outer world, the frictious forces affecting us are different. So the distance we measure at very high speeds near to the light speed has an error due to the fixed coordinates. This means that there is no absolute reference frame in the universe.
Taking a relook at our experiment, if we measure the speed by distance and time, the speed of the spaceship has to add up to the speed of light, but this doesn't happen. Why? Wait, there's something wrong over here.
This means that the fourth axis time plays a crucial role. There is an interplay between time and space. Both space and time change to keep the speed of light constant. There is one more problem to be tackled. If the distance is changing by delta x, for the speed of light to be constant, the denominator, time, has to be changed to keep the light speed at c. This is called spacetime. Spacetime is a continuum which records all events. To keep the speed of light constant, does the spacetime change? Isn't it weird? Are they intelligent like us to adjust?
Spacetime is a mathematical and physical construct that explains how space and time interact. The three physical dimensions and one time dimension combine to create the four-dimensional nature of the universe. It is a continuum because, so far as we know, there are no missing points in space or instants in time, and both can be subdivided without any apparent limit in size or duration. So, our world is embedded in this four-dimensional space-time continuum, and all events, places, moments in history, and actions so on are described in terms of their location in spacetime. Time and space are relative to the motion of an observer, and they are not independent of each other. This is not that strange. We often divide distances by the time it takes for light to travel between 2 points. For example, 1 light year is the distance light will travel in a year. To talk about an event, we will usually tell where and when it happened, like describing our daily routine of the event happened in spacetime. The scientific debate to find speed of light needed more than a brilliant scientist like Einstein. Hermann Minkowski, Henry Poincare, Lorentz, and Maxwell have contributed in their own ways, apart from Einstein, in determining that speed of light is a constant. In his famous quote, Minkowski said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." Minkowski's space diagram represents light cones, with two cones, one showing the past events and the other showing the future events. One can depict a particular object from the standpoint of its space-time representation. Every particle is located along its world line, stretches from the past to the future, showing the spatial location of the particle at every instant in time. This world line does not change with time, but simply exists as a timeless object. Maxwell found that electromagnetic waves should travel at a speed given by the combination of permittivity and permeability, the two universal constants of nature. Since the laws of physics do not depend on your location or motion, Einstein reasoned that the speed of light will be measured to be the same by any two observers, regardless of their velocity relative to each other. Two consequences of spatial relativity are: a stationary observer will find the length of a fast moving object is less than if the object was at rest, and the passage of time on the fast moving object is slower than if the object was at rest. The scientific theories predict that the space-time around our world is curved in nature. The same was confirmed by LEGO experiment in 2014. Thus, the research implies to a strange analogy that the xy axis, space and time, does change to keep the gradient, which is light speed, a constant. We shall get back to our experiment and apply some of the principles of space-time to see whether speed of light remains constant. Let us not deal with the mathematics behind it in elaboration, but apply some of the essential equations to get to the concept that speed of light remains constant. Let us see how.
Without reference, you won't be able to measure the distance between yourself and the person standing next to you at shoulder's length, because your shoulder length differs from his shoulder length. To put the question in the right perspective, how do we measure between two reference frames in the absence of absolute reference? We need a scale which is constant across the frames to carry out measurements, without which no comparison can be done. Albert Einstein has postulated it in the most eloquent way. Did Einstein derive the speed of light as constant? No. He intuitively assumed and set the speed of light as constant, and through sound reasoning, he justified why it is so. Let us see how it is with our experiment. One of the systematic limitations of the measurement of high speeds is what we measure differs from what actually happened. The curved flight path of the spaceship, as seen from our reference plane, is actually a straight line in the reference plane of the spaceship. Similar would be in the time axis. The curved path taken by the spaceship can be analyzed by a series of right-angled triangles. Because the spaceship is traveling near light speed, say c by 2, the light arrived at the Earth is seen as inclined, while the spaceship looks at it as a vertical line. Applying Pythagoras theorem, c square t square equals to v square spaceship into t square plus c square into t prime square after algebraic reduction. Lorentz transformation maps between reference frames my position at the origin with x, ct as reference frames. For the spaceship, it is x prime, ct prime. Both measure the speed of light constant shown by the 45-degree line. If the speed of the spaceship reaches the speed of light, the equation reduces to c equals to delta x by delta t. Hence, the total speed becomes c. Here we have the proof that speed of light is constant across all systems. Speed of light is a universal constant. It is a constant which holds good at the world around us, at atomic levels, and at galactic levels. It is a scale to measure the universe.